All right, let's solve a problem here. Let's see if I can do this. And I'm going to try to use the Notes app, and I'm going to paste on my iPad. This is an old iPad. I hope it works. Paste the problem from my email. There it goes. Okay. The problem is 330 milligram piece of gold with a density of 19.3, and they have a drawing here, into a sheet of gold leaf that has a length of 2.3 and a width of 2.35. They want to know what is the average thickness. Okay, that seems doable. They're saying that we have a piece of this material. Let's scroll down a little bit. Go to the pencil tool. We're going to scroll down. We have two pieces of information. We have that it's 330 milligrams of gold. I'll make it white here. It's 330 milligrams of gold. Okay, let's turn it to another color. There we go. And we know that it's 19.3. Come on, man. 19.3 grams per cubic centimeter is the density. And they want to know from the length and the width, given that of a sheet of gold foil that is 2.3 centimeters on one side and 2.35 centimeters on another. How thick is this? If it's only 330 milligrams, it's not very heavy, so you imagine it's pretty thin, and they want it in meters. That's the other thing, is they want it in meters. So let me erase this real quick. So the question is, how thick in meters? Well, what's our plan? Our plan is that they tell us here that the volume of a rectangular solid is, they tell us that the volume is equal to the length times the width times the height. And we have the length and the width. We're trying to find the height, right? So if we were to solve this mathematically, we would say the height, this value here, is equal to the volume divided by the length times the width, which we do have. Right? And then at that point, that's the height. You have the height. Now, that's what we got to. But we don't have the volume. We have the mass, and we have the density. So our plan is we have to find this. We're going to call this Roman numeral 1, and we're going to call this Roman numeral 2, because that's what we need to get. We need to get Roman numeral 1 and Roman numeral 2. I'm going to start with Roman numeral 1, and we're going to highlight that in yellow, I think. If I selected it, there it goes. This will be, I guess that's not getting highlighted today. Okay. We'll go back to our pen tool. There we go. Roman numeral 1, the volume. Once we get those two divided by, and it has to be in meters, then we're okay. So the volume. A couple ways to do this. I'll let the computer do some of it, and I'll do some of it. So it says we have 330 milligrams of gold, and then we want to know what is the volume of that in, well, presumably in cubic centimeters. So let's first convert the 330 milligrams to grams. So I'm going to say 330 milligrams in grams. I'm going to put equals here, and it should just do it for me. Solve. There, and it does. So we also could have done it like this. We can say that it would be 330 milligrams. And then when we do conversions, we always put a little, like I call it a train car. It's something on the top and something on the bottom here. I don't know why I call it a train car. It looks like a train of cars moving, right? If there was a square around this, but I don't dare draw squares around it here in Apple because it starts to try to recognize objects. And the next train car must have milligrams on the bottom, because things on the top, the numerator and the denominator cancel, and you're left with the thing that is left over, like no matter what that is. But we're going to do this in grams because we have a unit in grams. But we could have made this one long train car, and I'll show you both ways. We have 0.33 grams of gold. And then we're going to multiply that by whatever it is on the bottom has to be grams, because we always want the numerator and the denominator to cancel. So that's what those are going to do. So we're going to put our value is 19.3 grams per cubic centimeter, so we put the 19.3 on the bottom and the cubic centimeter on the top. I don't think this is going to solve this particular problem, and it's too hard for it to recognize all that stuff, especially since I wrote gold right here. I could probably erase that and it might try to solve it, but I don't think it will. But the answer is, maybe, let's see. Well, it did it. Okay, so it's 1.7 times 10 to the minus 2 cubic centimeters. Is that right? Let me try this in my calculator. 3, enter, 19.3 divided by, that's correct. Oh, that's okay. That's pretty good. So it converted the units for us. We could have also done this in one long train or we'll do it this way. We'll say or, come on. It can be done like as follows. This is 330 milligrams. Oops, sorry. 330 milligrams times 1,000 milligrams is 1 gram times 19.3 grams is 1 centimeter cubed. And this is the train I'm talking about. There's all these little cars you can imagine. You start with the thing that's specific. The thing in the front is the thing that's specific to only this time. So this is specific to right now only, right? And everything else is defined. The reason this doesn't change anything is if you start with something that's specific, like this value here, and let's just say that it's whatever, just some number. We'll just scribble a number so that's not trying to solve it. And no matter what happens next, if everything is equal to 1, you're not changing the value of anything, right? And since anything that has the same value on the top and the bottom is equal to 1, since 1 gram does equal 1,000 milligrams, then both 1 gram over 1,000 milligrams and 1,000 milligrams over 1 gram are all equal to 1. You're just multiplying it times 1. And you know this because if you were to multiply both sides by 1 gram, you get an equality, right? So essentially this is only multiplying everything by 1. I'll just erase all this to clean up my mess here. There. Now I will delete this because it's having trouble recognizing what's going on. And there's that. And if I draw an equal sign here, it may solve this as well. I don't know. That's quite a challenge. Oh, come on. Solve there. Well, it did it, and it's the same value. So there you go. That's our first value. So we're going to take that. We're going to call that. Let's just call it A. A is equal to 0.017098 cubic centimeters. Okay, we're just going to define that. And I think maybe I got a little too close. Here, let me erase some of this. A is equal to 0.017098 cubic centimeters. There, I think it recognized it now. Now we're going to go to part 2. because that is this value up here. That's the volume. So now we are going to go to the second part, which is to try to get the area. So the area is, what did they say, 2.35 centimeters by 2.3. Now, by the way, we haven't solved this for significant figures yet, but we get 3. So really, this will be turned into A equals 0.0171 centimeters cubed, because we can only get 3. We have to round this place up. So I will erase this with that note. I was going to do it later, but I should stop and mention it now for clarity. Oh, I'll erase this and go back. Thank you, Apple Notes. Okay, let's do the other one. Oh, it's just going to go ahead and it's still trying to solve this other problem. Okay, there's that one. The other one is we have is it 2.5 or 3.5? 2.35 and 2.3. 2.3 centimeters times 2.35 centimeters equals, let's see what it thinks. I don't know if it knows that that's a 5, because my handwriting is so terrible. And let me put this here and put a 5 in here. This is the centimeters. I don't think it knows. Let me try one more time. 2.3 centimeters times 2.35 centimeters equals. Oh, I got it. Okay, it's 5.405, but really we only get 2 significant figures, so it's just really 5.4 centimeters squared. So, oh, sorry. My bad. I almost made my own mistake here. Let's just erase all. This is in inches. This is in inches squared. So, all right. So I'll teach you how to convert that as well. Let me get rid of some of this. I made an error. All right, let's try again. 2.3 inches times 2.35 inches equals, let's see what it says. We'll try again. 2.3 inches times 2.35 inches equals, it's not happening. One last time. 2.3 inches times 2.35 inches equals. Well, that's weird. Oh, it doesn't know what that mark is, but it got the answer right. Let me try it this way. 2.3 inches times 2.35 inches equals. Let's see if it knows my handwriting. Yeah, I think it got it finally. There we go. It's 2.405, but 5.4. But it's only 2 significant figures. We only get the 5.4, right? So we can say that 5.4 inches. Whoops. Let's erase that. Inches squared in centimeters squared. And it will convert it for us, but I will also show you how to do it. There we go. It's 34.8, but you don't get any more or fewer significant figures, so you just get, the answer is just 35 centimeters squared, because you only get 2 significant figures. How would we do this without this thing doing the lovely math for us? We would just say that if you had 5.4 inches squared, you just take the normal non-squared version of conversion units. In this case, it's 2.54 centimeters is an inch, because that's something we should already know. And so we put inches on the bottom. So there's a 2.54 centimeters is 1 inch, just like normal, but then you just square everything. Square, square, square. And then, instead of saying equals, you multiply. You say multiply equals, and that's the answer. So what that is that you say 2.54 squared, let me see, is, hold on, I'm calculating it here, is actually 6.45. So we say 5.4 inches squared times 2.54 squared is 6.45 centimeters squared over inches squared. And then you have, the answer is, doing this manually, is 34.8. It's 35. Because we only get 2 significant figures. And that's centimeters squared. So if we look at what we have this value here, and we have this value here. So we say 0.071, what's the value? It's centimeters cubed, divided by 35 centimeters squared is equal to, and whatever that is our answer, is this many centimeters. So it's 4.8 times 10 to the minus 1, 2, 3, 4. We only get 2 significant figures, so it's 4.9 times 10 to the minus 1, 2, 3, 4 centimeters, but they want it in meters, right? So what is 4.9 times 10 to the minus 4 centimeters in meters, and whatever that is? Well, we can solve it ourselves. It's not going to do it for us, always, of course. Then we just say 4.9 times 10 to the minus 4. I don't know if it knows scientific notation. I don't think it does. Let's see. 4.9 e to the minus 4 centimeters in meters. Let's see if it knows. It doesn't. It does not know. Okay, so we will do it this way. We will write it out. We will say 0.00049 centimeters, and then we're going to say times, there are 100 centimeters in 1 meter, equals, and see if it does that. Yeah, we should be able to. So I don't think that did that correctly. So it didn't do anything at all. We will say it should be smaller. So it's going to be, the answer is 0.00049 divided by 100 equals, and that's your answer. So it's 4.9 times 10 to the 1, 2, 3, 4, 5, 6. So 4.9 times 10 to the minus 6 meters. And as a review, we go back up here and I'll show you that we have the length and width. It's the area, right? These two contribute to the area, which is this part. The volume we get from